Hello people and welcome back to another video. In this video, we'll be continuing from our previous discussion and we'll be solving a few problems on hypothesis testing and the process of rejecting the null hypothesis or finding evidence whether or not we actually have to reject the null hypothesis or not. In the previous session, we looked at some of the key concepts that we'll be following in the next few lectures, specifically when we are discussing hypothesis testing. These concepts included critical value and the significance level alpha. So if you guys haven't watched the previous sessions, I would highly urge you all to watch the previous sessions before you watch this session. So in the previous session, I demonstrated how to calculate the critical value, both one-sided and two-sided, when you have been given the alpha level. Now I have solved it for 10% alpha level and 5% alpha level, and I gave you guys a homework to calculate it for 2% alpha level and 1% alpha level. I hope you guys have gone through this once and you guys have calculated the critical values for both these alpha levels. Now we'll be solving two questions based on this concept of hypothesis testing. Let us begin. Let me just remove whatever we discussed in our previous session. And let's begin with a clean slate. All right. So let us read the question. A gym is interested in whether a 6-week weight loss training program they launched has been successfully has been successful in helping their clients lose weight. To assess this, they took a sample of 30 participants. We know that standard deviation of changes in weights over a 6-week interval is 6 pounds. The sample mean of the change in weight for the 30 participants in the sample was minus 2.98 pounds. Perform a significance test to determine whether the weight loss training program has been successful at 0.05 level of significance or not. We have looked at this question before, both when we had to calculate the test statistic and the p-value for a given sample, and also when we were studying how to hypothesize our null hypotheses and our alternative hypotheses right at the beginning of the question. So we'll combine all of these ideas together and we'll revisit all the previous ideas that we have seen in previous sessions while also implementing hypothesis testing. So let's get started. First, let us write down what all we have been given. We have been given sample mean. We have been given standard deviation. And we have been given number of samples is equal to 30. Again, if your number of samples is 30 or higher, then the sampling distribution start behaving like a normal distribution, and we can apply and basically central limit theorem is applied over here. So we will follow the Z test. So if we have to go step by step, as we have seen in the previous session, these are the 5 steps for carrying out significance test. Let's do it accordingly so that we have an idea how to solve a question on hypothesis testing. So step number 1 is set up the hypothesis and alpha level. So we have been already given an alpha level of 0.05. This is our alpha level. Okay. Now we need to set up the hypotheses for null and alternate. So the null hypothesis is the hypothesis of no change. So we'll say that the mean difference of weights before and after is 0. And we have to set up our alternative hypotheses. We need to find evidence that the weight loss program was actually effective. Therefore, we need to only consider the less than part of the alternative hypothesis. This is my alternate hypothesis. This covers my step number 1. Okay, this is my step number 1. Let's go ahead and see how the rest of the steps are implemented as well. What is the next step? The next step is select the appropriate test. Now, I have already mentioned right at the onset that since our number of samples is 30, therefore the sampling distributions start behaving like a normal distribution and we can apply the z-test. Also, we have studied that if the number of samples are greater than 30 and population standard deviation is unknown, then we can apply the z-test. And both these conditions are met over here. So we have to apply our z-test. This is step number 2. Step number 3, state the decision rule. Now, before stating the decision rule, you need to calculate two things. One, you need to calculate the test statistic for the sample, and second, you need to calculate its p-value. Let us do both of these things right now. So my test statistic or z value is going to be x bar minus mu s divided by square root of n. And my p-value is going to be since I am concerned with only calculating the less than part, or I'm finding evidence for when mu is less than 0, then I'm considered only with the left hand side of the test, which is why I'll be just doing p norm of z. Alrighty. Let me go to R and do both of these things. I'll initialize x bar. We've been given the value minus 2.98. Standard deviation is given as 6. Number of samples is 30. Now we have to do z value as x bar minus my new value is 0 divided by s divided by square root of n. Now we already got the z value or the test statistic as minus 2.7203. All right. So this is going to be my z value is equal to minus 2.7. Sorry for the mess up. 7203. Okay. And we need to calculate the area towards the left. This is going to be my p-value. If I do p norm of z, I'll get 0.0032. Let me erase all this portion, not needed as of now. Even whatever is down below, let me just quickly rub this off. Alrighty. So we got this value as 0.0032. All good. So this is step number 3. This complete thing is step number 3. I hope you guys are following. Now, what is step number 4? Step number 4. So the step number 3 is still not particularly complete. We need to still form the decision rule. So the decision rule can be formed on two bases, as we have seen in the previous session. Either it can be formed on your p-value or it can be formed on your test statistic. So my p-value it's written over here. If my p-value is less than or equal to alpha, I have to reject the null hypothesis. If it's greater than, then I have failed to reject the null hypothesis. So in this case, my p-value is actually less than or equal to alpha because alpha is 0.05 and my value of test statistic is 0.0032, which is less than or equal to 0.005. So in this case, I can reject the null hypothesis. That is something that I'm already seeing. But this is what the decision rule is. It can be based on p-value or it can be based on test statistic. Now for test statistic, if you want to do it if you want to do it based on test statistic, then you need to calculate the critical value. So compute the test statistic and p-value that is already done, but you need to also calculate the critical value. So to calculate the critical value, you already know that it's one-sided. Second, you know that the alpha level is 0.05, so we have to do it along 95% confidence. And finally, you also have an idea that this is my critical value. This right here is 95%. So this right here is 0.95. I'll go back to my R. I'll say Q norm of 0.95 and I'll get 1.644. So my Z critical comes out to be 1.644. And you now have to compare this Z critical value with my test statistic, or I should say more of test statistic. So while we are comparing test statistic, we only have to be concerned with the magnitude, not essentially the sign. So you need to compare the magnitude of test statistic with this. If you are taking the sign element of it, then you need to consider the negative value of the Z statistic or the Z critical and compare it to that. But we don't want to make things complicated because we are concerned with this particular Z critical and not minus Z critical. So we'll be taking the more of my Z statistic, which is nothing but 2.7203. Now, if I'm comparing this with 1.644, then obviously this is greater than or equal to 1.644. So even in this case, as the condition says, if your test statistic is greater than or equal to the critical value, you reject the null hypothesis. So my test statistic is greater than or equal to my critical value. Therefore, I have to reject my null hypothesis. So this is just one of the examples on how we should approach a problem on hypothesis testing and how to do it step by step. Now we will go over one more question, but this time rather than having it one-sided, we'll be having it two-sided. So let me rub all of these off so that we can begin fresh for the new question. Okay. So the question says, county officials were interested in measuring a particular chemical in water source in the county. High levels of this chemical are as harmful as are low levels. Normal levels of this chemical are 15 parts per million. Samples from 50 water sources throughout the county are taken and the levels of this chemical are measured. Suppose we know that the population standard deviation is 6.2, the sample mean from 50 samples was 16.4. A significance test was conducted to determine whether the mean levels are different than 15 ppm at alpha level is 0.05 of significance. So again, we'll approach this question the same way we did it last time, but I'll be just going over the steps quickly this time rather than taking each step at a time one by one. So first, as we can see, number of samples are 50. Therefore, my test is going to be a Z test. I also know that my null hypothesis is nothing but my mean is equal to the normal levels of chemical 15 and alternate hypothesis is mu not equal to 15. So and you have been also given alpha as 0.05. Next, we move on to our next step when we have to calculate the value of the test statistic for this particular test, which is for a Z test is going to be per mu divided by sigma by root n. You have been given your x bar value as 16.4. You have been given sigma value as 6.2. And you have been given number of samples as 50. So Z value is going to be 16.4 minus 15 divided by 6.2 by square root of 50. This is going to be my test statistic for this one. If I have to calculate my z value for this, it's 1.5967, or you can say 1.5, almost 1.6. We'll round it off as 1.6. So now if I have to calculate my, so if I have to do my hypothesis testing using the route of test statistic, then I need to calculate my critical value. And because it's double-sided and my significance level is 0.05, it means my confidence interval is 95%. This right here, this is 95%. And these two are equal. So if I need to find my Z value, then I need to go 0.95 plus 0.05 divided by 2, which is 0.025, which is nothing but equal to 0.975. It's coming out to be 1.9599, which is almost 1.96. This value is 1.96. So in this case, my Z critical is greater than my test statistic, or Z. And we studied, if my critical value is greater than my test statistic, then we are failed to reject the null hypothesis. Please go ahead and watch the previous few minutes of this video once again if you haven't understood what I've done. But more or less, if you're following the sessions, you would have understood what I have done. It's pretty simple, nothing extremely complex and complicated. You calculate your test statistic, you calculate your critical value at that confidence level based on it's one-sided or two-sided, you compare the two and you get the result. However, if you guys would have wanted to do it from a double-sided perspective, then, or rather I should say, if you guys would have wanted to do it, it is a double-sided test, so pardon me, if you guys wanted to do it from a p-level perspective or a alpha perspective, then you need to calculate the p-value for the corresponding Z statistic. And for a double-sided test, how do you calculate the p-value? This is plus 1.6. This is minus 1.6. You need to calculate both these areas. This is going to be twice into 1 minus p norm of 1.6. This is going to be my area corresponding to this, because this is going to be, these two areas are equal based on the property of standard normal distribution. So if you just calculate this particular area, it'll be easier to multiply it by 2 and get that area. So we'll do exactly that. So my p-val is going to be twice into 1 minus p norm of 1.60, and this comes out to be 0.109, or rather, oh, where's my word pad? Here we go. It comes out to be rather 0.11. This is way greater than alpha. 0.11 is greater than 0.05, and therefore you have to reject the null hypothesis. So from both the test statistic perspective and from the p-value perspective, you're getting the same result. This is how you need to approach questions which are on hypothesis testing. So I hope you guys have enjoyed this session. I'm looking forward to see all of you all in the next session, where we'll be going on a few more interesting problems on hypothesis testing, so that you guys can have a firm grip on the concept, and you and after repeated practice, you can be at a stage where you are able to comprehend and solve the questions on your own. So again, thank you so much all of you all for watching. I'll see all of you all in the next video. Thank you.